Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Camera Tuesday, we're going to talk about Cinema Lenses 101. So let's dive deep into it. So we are talking about cinema here. So it's more about look and feel of it rather than basically how sharp it is. Now there is a mathematical unit of basically quantifying how sharp it is, which we call mean transfer function, mean function transfer. Basically, if you have a perfect sensor and if you have a perfect pattern, like perfectly sharp edges, how much of that detail can be transferred? Now again, if you are going through lenses, you can't transfer much. There is a fundamental limit to it. If somebody says, no, we are shooting in 16K, no, you are taking a digital file of 16K. You don't have 16K of detail. Why? Lens cannot transmit that. The only way, basically observatory level or spy satellite level lenses can do that, and they are huge. They have to be huge. Otherwise, light, if you are folding it that much, it just does not like it. Then how the heck telescopes deals with that? They do not have lenses. They only have mirror. You shall not go through it. You should go twing from it. So again, reflecting from few basically atoms of aluminum versus going through things, duh. So fundamentally, when you're talking about movies, while people can talk about it, while Christopher Nolan can sell you cocaine, where it's like, no, we have shot in 18K, it's like, nah, bro, it's 4K. How do I know it's 4K? You mastered it in 4K. And that film, it's film. No, it's not film. It's a digital file that was projected on a film. There is a company that does that. You can see behind the scene how they do that. It's 4K. Digital file is always 4K, like the master file as we call it. And it's just recently switched to 4K. Back in the days, we were still using 2K, which is just a bit bigger, what we call full HD, so to say. So let that be very clear. It's not about resolution. It's more about look and feel. And of course, when you're talking about like a very high bit depth, very low compression or no compression, even full HD is GG and 4K is like more than enough, assuming your lenses are actually transferring that much detail. So whenever you are talking about this sort of equipment, you have to understand they are only used by professionals and for professional work, meaning not only they are getting paid for their task, the work itself is also making money. For example, if you're talking about wedding, you are the professional one. That's cool. You are getting paid for taking that photo. That footage is not printing money. But when you're talking about movie, both are pros, meaning you are getting paid to do that work and that work is also making money. So price becomes a no object in this sort of scenario. And whenever you are dealing with this, the first requirement, it cannot have mind of its own, meaning it cannot do anything that is not asked of it. Meaning if your lens is like, hey, what if I do this? No. What if I like breathe? No. What if I compensate? No, nothing. It cannot do anything other than what exactly cinematographer asked for or wished for. Like it has to be absolutely, I am a dumb device. I do exactly as I'm commanded, meaning it has to be outside of the program loop, so to say. It cannot interfere or color or anything like that. And in this whole sector, cost is not an object. Why cost is not an object? Why you like $10,000 is like, oh, that's such a cheap lens. It's like, why $10,000 is a cheap system? Well, simply because imagine in this way, let's say you are shooting Top Gun. What do you think is the cost of having a fighter jet? Yeah, you can't buy it. So that means there is a temporal window, as in like in this time, shoot your movie. Failure to do so, we do not care. Your movie is kaput. Or if you are shooting, let's say, a racing movie like Ford versus Ferrari, what is the time of getting that vehicle? What even if it's a stunt system, it's not free. What is the time of that? What is the time of renting a basically stunt driver? What is the time of arranging the whole circuit and all that? And lighting, which again, so like, yeah, it has to be golden hour and whatever have you. Yeah, what is the priority and cost of that? Is shut up, take money. Meaning if at this point of time, if camera lenses is like, yeah, it's misbehaving, they're like, yeet, put a new one. Ain't nobody got time for that. Again, even in a Bollywood movie, like you have so much set actor, actresses, lighting, VFX, sometimes particle effects, all of those things combined, camera and lenses become free. Like at that point in time, those things are free. So this is why whenever you are talking about cinema lenses, money never enters into the picture. Because if you are dealing with such an expensive thing, money would be like, you penny pinching. It will look like penny pinching. So that's the cinema lens ecosystem, so to say. Now let's understand the first aspect, control. I said it has to be a dumb device. What does that mean, translate to? That simply it cannot have drive-by-wire. For example, back in the old days, all photographic lenses were basically manual, but slowly they had autofocus. Then slowly, right now, the current generation lenses, they don't have anything that is physically connected, meaning you're like, okay, I'm zooming in. No, you're not. Easy way to test it, basically disable your camera, turn it off, rotate the ring. If lens inside does not move back and forth, that means it's a drive-by-wire. That is not acceptable in cinema. Thou shall not do it. It has to be like, oh, I move this much, it has to move exactly this much. It cannot be like, oh, the encoder pulse was missed, so the computer moved it little bit back or little bit. Micro Four Third was really bad into this regard. Like, they were really bad. They wanted to cheap and small lenses. That does make you, allow you to make cheap and small lenses, but they messed up the encoder part. They're like, it has acceleration value. It's like, why? Who came up with that? Here, nothing like that. I move this much, it moves that much. That's why you will always see their rating is very precise, like 1 feet, 2 feet, 5 feet, 1 meter, 2 meter, 3 meter. It's like precise, and it always works. That's what it means. The lens cannot be in the picture. Lens is like, I do a job, the end, go home. So there cannot be drive-by-wire, and autofocus are very rare. Generally, they are only found in cheaper end, which are trying to be TV lenses, electronic news gathering lenses, sport lenses, and a cinema lens. Generally, you do not want to have autofocus because, again, it inherently adds a motor. Even if it's a clutched motor, like back in the old days, the DSLR lenses, many of them are clutched, meaning my this system, if I move it, the lens actually moves. But then how the heck motor drives it? There is a clutch. So it's very rare. But again, you will still have mechanical coupling. And focus, zoom, and aperture, all this will be manually accessible. Ironically, photo camera has to use that. They used to have that. Then they slowly went inside. Now they're coming outside, but they are coming out digital, drive-by-wire, meaning all the Sony lenses, you can rotate it, like aperture rarely moves. Some of them still have that, where it's like a mechanically coupled, but many newer ones is like, you can change it. So focus, zoom, aperture. Now zooms are rare, but still there, and all the options have to be like big chunky gears. And be mindful, the reason why they look like gears, they're not supposed to be used by hand. You can use them by hand, they're not supposed to. They're supposed to be used by a gear knob, either electronic one where some other individual could be doing it wirelessly, or some person literally next to the camera doing, like a focus puller we used to call them. So all of those are there. And one thing, even if you can get a autofocus system, thou shall never get a basically optical image stabilization. That is a big ass no-no. Why not? Well, whenever you're talking about optical lens and it has an optical axis, to basically stabilize the lens, all you do is move a core element of it. Counter movement, meaning if your lens is going down, you move it upwards. So you counter move this puppy. That means it has to float in two axes. Only then the electromagnetic coils can move it. That means if you are moving your rig like that, it will have its mind of its own. For example, if you look in the old movie like Iron Man 1, when they were shooting it, they were shooting in film camera back in those days. So they had a Humvee scene where Iron Man is there and the boom event happened and they had to record it. But how would you show that feeling, that whoo, the jerk? So they came up with the idea. They had a drill. I'm not joking, this like behind the scene is available. You have a giant film camera, you have a guy with a basically drill, and that drill has this unbalanced mass attached to it. It's like that's how they're getting the shake. But again, imagine if you had a floating element, because even if it's not electrically powered, based on its own inertia, it will lag back behind a bit, and that will change the look and feel. So it cannot be there. That, like, every element has to be fixed. And again, you can even notice that with camera, when they have IBUS, you can shake it when it's powered off, and it's like sounds like something is shaking around. It's IBUS. That's why cinema camera bodies, they are always hard locked, because you're supposed to do external balancing, meaning either use gimbal or use glide cam, whatever have you, but it has to be external, meaning you intend for it to be stopped. Only then it will be stopped. You will not interfere. The lens is like, bro, it's not my job. You are giving me shaking data, I give you shaking data. I do not compensate for it. And if you're like, hey, I want song actions and all that, high action moves, all that, cool, sir, cool. Please buy global shutter. So that's there. And the frames are generally meant to be very robust mounting option, because again, you generally will have a lot of electrical equipment added onto it, or a person literally doing like this. So it does require a bit of oomph, like it cannot have plastic and creaking and all that. So for that rigidity reason, it does generally, not only the mount is also robust, the whole frame, because again, you're pushing against it, is also robust. So control, meaning it does not interfere. It's just like, I do not care, I do not exist. Perfectly transparent. Now we come to the science of it. Now let that be clear. It's still about look and feel, but science has to be good enough where it's like, now let's worry about look and feel. So generally, why the heck it goes from this to this puppy? Well, there is a physics aspect of it. Again, lenses are not good. If you want good, you will use mirror. That's like, look into James Webb telescope. Not a single lens. Like nothing, not even in the instrument way. Nothing. So What do you do with glass? Well, if you have to deal with glass like these puppy, the best thing you can do is make sure they are huge, because if the bigger you make them, the less light has to bend. For example, a glass disc is this small and you're bending like this much, bad. But glass is huge, now you're bending. So less you bend, the less aberration it incurs. So less counter correction lenses you have to add. Benefit, exponential gains in quality. Penalty, size is huge, weight is huge. So that's why it's not suitable for photo camera. Photo camera, we want to compact the lens formula as much as possible. In cinema, we want to throw away. Like if you throw this many glasses, they're like, yeet, thou shall yeet that lens. Make it big, make it few elements. That's the core essence of it. The less contraction you're doing with your life is like and like no, it's like easy and smooth. So that's why generally it will be huge. If you look into RE glasses, they're like so, and they are tailor made. They do not have focus breathing, and this is a very critical aspect. And like, does focus breathing matter? Yes. Why? Because again, you must have seen people doing like this. The reason for this is back in the old days, even now, you have a pole guy, basically the guy who's like literally trying its best to be out of the frame and making sure the audio is captured properly. And many times directors or storyboard artists will be like, hey, what if we put some scene here and have some background, and it's like, oh, tada, the mystery and all that. So the framing is very tight. It's not like breathe in, breathe out. No, it's tight, it's precise. You cannot be precise if lens is interfering. If lens is like, nah, man, I'm feeling like this. It's like, nah. You shall not think. You should just focus. So they have to make sure that there is no focus breathing. And again, you must have seen behind the scenes of, let's say, one famous one is Jack Snyder. He generally literally has the same cinema glass. Like let's just say his camera has 35 he'll take that cinema, there is a hand handle, and he'll put it there and look through it. That's the easiest way where you can like, okay, exactly how much area I'm seeing, what is the composition, how things are popping in and popping out. So you can be damn sure the focus breathing is like, no, just like, no. And another aspect is that maintaining focus while, you must have seen the people zooming in and then background going out of blur, or reverse dolly shots. Those shots, I never understood how the heck it was done, because that meant somebody was doing three things basically, not three, two things at least. They are zooming in and they're focusing also. It's like that was not possible, but again, it's not possible easily. So the only way to do that is having focus elements and zoom elements completely separate. Now be mindful, that's a normal thing even for broadcast lenses, news lenses, and cinema lenses. Then why don't we do that in our photo lenses? They are huge. Like your lens, let's say 70 to 200 would be like this, and if you have that free floating elements, ta-da! That's why people don't. And if you look into sports videography, whenever somebody is doing that giant box, yeah, because focus elements and zoom elements have to be free floating. It can be done. How the heck modern cameras compensate for it? They realize people open their mouth for everything. It's like, I want this. It's like, no, you don't. If I give you that weight and mass and all that penalty, even if you can afford it, you'll be like, nah. So what they did is like, now you have electronic autofocus compensating while you're zooming in. So, but again, for a movie, that's like, no. So to have that no, you must always have what we call parfocal systems, independently moving the focus lens groups and zoom lens group. So that's how we make sure that there is a reason why these things are so huge. It's not just like lol. Although some lens elements are lol because they are like, hey, our 30, like let's just say this photography, like people are loving it. What if we just repackaged it in cinema? They do that sometimes, but not recommended. And there is a reason why there is a completely different brands who only deal with cinema glass, and there is like, no. If you come, if you open your mouth with like, oh, Canon, no, Canon is for poor people. I was like, damn. So fundamentally, that's why the glass element is completely different philosophy. Size and weight does not matter. The quality matters. It cannot have like breathing or parfocal events in a zoom lens scenario. And glass elements has to be as big as possible in order to have minimum distortion as possible. Then we come to the transmission aspect of it, because whenever you're talking about f-stop, you're talking about a mathematical ratio, meaning the input divided by output, that's your f ratio. Now that is true, that does give you absolute rigid calculation of what is your depth of field. That's the good part, GG. But here's the problem. Like let's just say you are you had a kit of Holy Trinity lenses, and you're like, you know what, I'm shooting 70 to 200, everything is fine. It's like, you know, I'm trying to compact everything. Now you're on a close-up shot. Now you went into, let's say, 24 to 70, f2.8. Now like, wait a minute, why the scene is brighter is like f2.8 of your zoom lenses that may not be exactly f2.8, meaning the transmission, as in like if you had 100 watt of energy here, how much went into your sensor, that's not 100%. Mirrors come very close to like 99.95, but lenses are like lol. So if you have 100 watt of energy here, only few percentage will get there. Like in this scenario, they are showing you 100, you'll get 95% there, but you have to know. How would you know? Well, we created different measurement unit that measures that part exactly. Meaning, if you use f-stop, you will know precisely depth of field. If you use t-stop, you will know precisely how bright the system is. Meaning, for example, back in the film days, film era, there are still some people who shoot in that. You cannot change ISO. It's like it's hard coded. It's like physically that's how the size of silver halide crystal, the end go home. So it has to be matched. There is no discussion about that. And then we come to digital. You're like, okay, we can change it. No, there is no such thing as ISO. You literally have one circuit most of the time. You just have one circuit. Your sensor takes the data gets digitized, what we call analog to digital converter. It has a base ISO. Whenever you hear about people base ISO, that's what they are referring to. Again, electronically, it may be referred to as a base noise line level, but you get the point. That's there. And whenever you hear people are dual gain ISO, there is a second circuit. It's like, okay, now you want better low light performance, then you go to second circuit. So generally, there is no such thing as ISO. It's just a digital add-on. That's why in raw files, you can just change your exposure. And it looks exactly same as if you change the ISO. ISO only exists for compressed formats, not for large ones. And again, as a cinematographer, if you paid for a camera, you will pay attention to like what is the sweet spot. Let's say ISO 800, the end. Every shot will be made sure that it works with ISO 800. If it's not bright enough, you put lights into it. If it's too bright, you put ND filter on it. You do not touch that. You're like, the end. Go home. Thou shall not tamper with it. That's why T-stop is such an important thing. Meaning if they're like, hey, the T-stop is like, let's say, T2. Other lens has to be T2, only then you're going to swap it. Otherwise, you will be like, lol. Even though f2.8, both could be f2.8. But if it's a lower quality glass, the transmission would be bad and the scene ISO will go down. Then the colorist will look at you badly. So there is a science reason behind it. So size and weight, there is a reason for that. And they are paying specific attention to transmission also. And be very mindful that f-stop would always be slower than t-stops. F-stop would be always larger number. For example, if somebody is making lens f1.2, the t-stop cannot be f1.2. T-stop will always be 1.3. T-stop is always lower than f-stop. Equal, but again, only mirrors can do equal. Lenses can't. So that's the science aspect of it. There's a genuine reason why if you look into some RE lenses prices, you're like, what are they making it out of? Well, lot of glass, like lot of large glass. Now, another aspect is because we are generally dealing with prime lenses, and even if you are have the ability to shoot in zoom, you want a set where you do not change the color and look and feel. Now, it's like, why does that matter? Your eyes need travel distance. For example, you can take a full frame camera, same photo, exact same sensor, exact same lenses. You project it in your mobile phone. Half of the detail is not there. Same full HD mobile phone. Half of the detail would be lost. In this, you will notice some more details. Same full HD. You project in an IMAX screen, you will notice far more detail. Why? Your eyes have time to scan it properly. So that's why when you are exposing something tiny and exposing it to larger area, all the minor imperfection that you did not even pay attention to becomes like, whoa. So for that reason, color shifts are like, no. Now, like, what about colorist? Well, ideally, colorist wants to receive flat files. They want to color how you want the movie to look. Don't want to, scene A, scene B, they do not want to match that part. It's like, bro, that's how it should be. Like, specifically if you change lenses. Yeah, if you had to change cameras, which again, sometimes you will be like, they have a main camera, that is the main thing, but they have a crash cam. Then it would be a specific hassle for them, but they will deal with that. But you do not want your main cam to be like, oh, main cam lens number 1, main cam lens number 2. It's like they want that to be as little as possible. Only then they can, like, sweetly match it. Because again, double correction is never a good idea in digital file. It can be done. It does work, but it's like, it's like, it's too obvious, especially on an IMAX screen or any sort of projected large screen. You'll be shocked how little all of these things starts to like, duh. So that's there. And audience cannot notice lens switching. That's the prime aspect, meaning unless you want your movies to have cuts like Star Wars, it's a one thing. But in most scenarios, you do not want when cut to happen. Like, people should not notice. It's like, oh, you are switching lens. Oh, you are switching like, it should flow. So you have to work your ass off to smooth out everything that can interrupt the flow. So That's why lens switching cannot be noticed. Lens cannot have properties, different properties. So they are generally matched. Now, like, what does it mean to be matched? Generally, whenever you are talking by, let's say, Holy Trinity lens, you have 70 to 200 and then you have 24 to 70. Generally, two really good system. But even if you're buying them from, let's say, Sony Z Master, they are different. They could literally be made in different ways. So one could be made in Vietnam, another could be made in Philippines. You do not know. They could be made in the same factory, but they could be made in different batches. You do not know. But whenever you're talking match set, like crooks, generally they will literally pour the glass, and that glass will be consumed in all these lenses. So everything is perfectly aligned. So 75 will have exact same properties as 35, 25, 65, 100, 150, all of them. Why? Because the mold, the glass material, stock material was same. So if they have aberration, all of them will have exact same aberration, allowing you to make sure the lens switching is smoothless. Basically, it's just smooth. And on top of that, once they have done that, because again, these are expensive puppy, they do optical matching, meaning they will put it in a very scientific instrument and calibrate how the heck each things are working, and they will not create a full set if one lens is like, lol, I'm out. So they will remove that system. They'll remove the lens, because lens, again, they generally come in briefcase for this reason. All the lenses, they are serial number, they are generally boxed. Not all manufacturers do that, but you have to. It's like, if there is a reason for it. It's like color changes would be negligible if the glass stock was same. The only way to keep the glass stock same is manufacture them in the same time, in same factory, in everything be as same as possible. So they're not mass produced items, so it is that compounds on it. It becomes more idiotically expensive. But again, that's why you generally see briefcase of it, and they are expensive. Like, if you think photographic lenses of Sony and all that is expensive, lol, look into Crook's lens prices. You're like, it's one whole different. But again, they are matched in one match set, and optically matched for certainty, meaning a company will certify it. No, this is matched. If you are having issue, either your camera bricked itself or somebody changed some setting. Nothing else should be there. That's the whole point. That's what you're paying for. It's like, I do not want to think about it. And again, before a movie shoot, sometimes people do a trial shoot. It's like, I want look and feel, because again, it comes back to the same thing. Lens does not matter. Lens, all you are paying for is lens to disappear. But again, you may be like, hey, I really enjoy this. Or heck, you can be like, you know what, well, the vibe that I'm looking for, it's coming in Sigma lenses. Go YOLO on it. It's, at the end of the day, that's what is paying you. So it's up to you. But again, that's why lenses are so expensive. They are made in match sets. Sometimes they are actually bidded on, because again, they are so expensive, so rare. They are generally rented, and there is only few set of it in California, in Mumbai. They are not something that are like hundreds of them are exist. Like, surprisingly tight, and people have to bid on it. It's like, hey, I want it for this shooting. And again, sometimes directors' names have to be used. It's like, bro, Christopher Nolan, bro, come on, bro. It's like, so it's like a completely different world. Again, not all cinema lenses are that high caliber, but it's not about that caliber. It's more about that look and feel. Like, I like that feeling the end. If I have to delay the shooting, I will delay the shooting. And yes, that has happened. So this was my presentation on basically what the hell is the deal with cinema lenses. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show makes this movement. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon for free, and as always, thanks for watching.